Before we start, I wish to acknowledge the traditional custodians on the lands on which we are meeting. Here in Canberra, it's the Ngunnawal and Ngambri people. I wish to recognise and acknowledge the elders past and present and any Torres Strait Islanders who may be here today. Janelle, stop playing. So everyone here in the room, we would very much like to welcome you to the ACS Canberra Hub. This place here has been open since December last year. We had our official opening last year. And basically, we would encourage all of our members, both here in Canberra and anyone coming to Canberra, visiting for work or any other reasons, to please feel free to come in and join us and have a look at our space. Very much welcome to be here. And also for anyone who does have any connections with any meetup groups locally, very welcome to host those little groups as part of our part to the community, giving our part to the community. This slide here, you can see that all the benefits of the ACS. Essentially what we are here for is to ensure that we have the number of people that we need for the 2027, which is that 1.2 million people. Ensuring that we are all successful in terms of the technology that we need to have for those times. We champion the critical infrastructure and critical technologies to keep Australia globally competitive. And more importantly, is that we're here to make sure that we are, that as a community, that we are contributing to the broader community. So as a tech sector, we're contributing to the broader community. Being that through making sure that our community is reflective of the general population in terms of its diversity, but also ensuring that we are showing how we can contribute to issues such as environmental sustainability and our lifelong benefit and economic benefit. So on this slide, you can see many of the different benefits to ACS membership that goes from knowledge through to networks and recognition of skills and capabilities. But today, it's my great pleasure to introduce to you our speaker, Dr. Alex Antic. Alex has 17 plus years of experience developed across a number of industries and domains, including federal and state government, insurance, asset management, banking, both in investment and retail, consulting and academia. He has experience in leveraging data science, AI to deliver impact and change by delivering and managing high-performance teams and via strategic advisory and technical expertise. Alex has recently been recognised as one of the top 10 analytic leaders in Australia by the AIPA, which is the Institute of Analytics Professionals of Australia. So you can follow Alex on LinkedIn. It's very prolific. Also on Twitter or on his blog, which I'm sure Alex has some links to during his talk. So with that, I'll invite Alex to the stage. Thanks.
Thank you, Vicky. Everyone at the back hear me okay? I don't tend to speak loud, so please tell me if I need to raise my voice. I should be on, yes. I will confirm for you, Janelle. There's a green light, so it's on. So, has anyone heard of ChatGPT? I assume most people have. So, there's a lot of hype around AI these days, which is both good and bad for those of us in the field. And one of the good things about that is that it's raised a lot of awareness in organizations for the need for data science or a data analytics capability. What it's also highlighted for many organizations is that they don't really know what they're doing sometimes. They don't know how to begin their journey or they don't know how to scale their journey. So my aim tonight is to hopefully share with you some of my key learnings and observations, provide some guidance and advice that I've achieved over my 20-year plus career. I'm not young anymore. And to hopefully give you some takeaways that you can apply directly to your roles or to your careers when you leave here tonight and start thinking about what does it actually mean for me and my job, my role, my organization. Before we get into that though, I think it's important to understand and discuss why is data science itself important? Why do we actually need it or think that we need it? And also, what does data science actually mean? How do you define it? That's something that people often gloss over, but I'll have an attempt to give you a definition that I've developed over a number of years now that I think encapsulates the key ethos behind data science and how it's actually used effectively in organizations. Why is data science important? I think there's two real reasons why most organizations need it. One is data, obviously. It's a necessity to do data science, you need data. But often people talk about this huge amount of data that we're all exposed to. We're collecting data, there's zettabytes of data, there's statistics around telling us how much data is being produced every day. But in my experience, for most organizations, it's not really the volume of data that's really a problem, it's the type of data that they're collecting and that they struggle to deal with. And specifically, I mean unstructured data. ChatGPT, go back to that example, is a good example of how you can potentially leverage that technology to work with text-based data to uncover insights for your organizations. But that also includes audio and imagery, of course, computer vision and technologies like that. So traditional techniques that I would have started using in my career many years ago now, traditional statistical and mathematical modeling techniques, don't really lend themselves too well to analyzing such technology and such data and the technology that we had at the time. So these days, data science and everything it encompasses, from deep learning to the tech stacks that we use, make it so much more easier. The barrier to entry is so much lower now to leveraging the text-based data your organization may have for you to try and develop some insights to drive your decision making. So it's really the type of data that's caused us problems and where data science comes to the rescue. And the second reason why I think data science is important is humans simply don't scale very well. It's a scalability element that really can help us to a large extent, where in the past, it may have meant throwing more analysts, intelligence analysts, quant analysts at a problem, and you'd get definitely an immediate increase in your capability. These days, given the volumes and the type of data that we deal with, and the push for real-time analysis, means that the technologies that underpin data science make it so much more easier for us to actually deal with that at scale. So scaling our capabilities with the data that we have is where I think data science really comes to the fore. And there are many other aspects of data science that we won't touch on directly, but I'll touch on during the talk, that encompasses the ideas behind why data science is actually important and prevalent, and why most organizations need to understand how do you actually invest in it and have the correct capability, which is still a challenge for many. I also said I'd give you a definition of what I think data science is. For me, data science is a science of change. People often ask me after I've given this definition and say, look, you haven't talked about technology, you haven't talked about ML, deep learning, R, Python, and all that. Sure, they're all necessary for utilization of data science, but they're not sufficient to define what it is. Data science is really a means to an end. It's for an organization to be able to meet its strategic goals using the data it has at its disposal. The operative words here, science and change. You can't forget the science element of data science, and I'll touch more on that later in my talk. You can't treat it like most IT specialties. It is quite different and unique. And also, you have to think about the change that often has to go hand in hand with a data science capability, at least when you're trying to scale and have an enterprise-wide capability within your organization. That is something that catches a lot of people out. They think it can be quick and easy and cheap to do data science. And in time, they realize that's not necessarily the case. If it is, you're doing well, but more often than not, you have to actually invest. Invest financially in the capability, invest in the right people in the right roles, and also invest in the change, the cultural change that's required to enable and support data science in an organization. And that can be quite confronting for many organizations. And something I come across often throughout my consulting business is, we think our culture is great. We think we're doing the right thing. Why do we keep failing? So the first thing I can tell them is your culture isn't as great as you think it is, which they don't always want to hear. And another point, as is on a detail on the slide, to really reap the benefits of data science is, as a leader, as a data scientist, you really need to have that clear connection between what you're doing in data science and the strategic goals and pain points of the organization. You need to be able to literally map it and show your manager, your CEO, the board, whoever it is, how what you're doing is actually providing benefit to them against certain strategies that they've listed as an enterprise-wide, vision or goals for the organization. That helps with securing your role, it helps with securing funding, and also helps securing in them a notion that you have the goals of the organization in mind. You're not there just to do some pretty and sexy data science and analytics, which a lot of younger people get caught up in, and I can understand that. So The alignment with the strategic goals is really key, but also having measurable outcomes, being able to quantify your results as best you can, which can be tricky. It is a science after all. That can be hard sometimes. Doing that as best as you can, I think, is the benefit of everyone in an organization. So now that we've kind of given a background to why data science is important and what it actually means, I'll now attempt to give you what I think are the magic 5 elements to achieving success in your organization. Topmost is really people, and I'll speak quite a bit about that. So if you only remember one thing tonight, is that the people element of data science is absolutely crucial. Forget about technology, forget about data even at some point. It's the people that are actually, key to the goal. The tools, of course, the data are important, necessary, but not sufficient to achieve success. You've got the tools and technology, the whole stack, which is, of course, imperative. It's all built upon that. You've got the value proposition, that alignment to strategic goals. And then you've got the communication part. If I was to take 2 of these and say which are the most important, I'd say it's the people and the communication. And we'll touch on why I believe that as I progress through the talk. People, why are they so important? I like to think of it in 3 tiers. The lowest level, you've got your actual practitioners, your data scientists, your analysts, your engineers. They're doing the brunt of the work every day, day in, day out. They take your data and produce some insights. Then you've got the team leader at the second point. That could be an EL2 within the APS government. It could be a manager, senior manager in the private sector. And sitting above them is your senior data leader, these days most commonly known as a chief data officer or chief data analytics officer, and hopefully not a CIO, which I'll talk about why later. That person is crucial to enabling success in an organization and for supporting the enterprise-wide capability. But there are some pitfalls that some organizations get into there, and I'll touch on them. So your data scientists, your software engineers, your data engineers, you need to understand what drives these people and how to hire actually the right person. If you don't come from a data science or tech background yourself, this can be challenging for some managers, and I'll speak about that in a moment. You need to realize what skills they really need. What are some of the current and emerging skills that they should have for your organization to leverage the data and capability you have to meet your strategic goals? And also, what actually drives them to succeed? Like, you have to think of them as people. They're not just robots or tools for you. They're actual humans with different needs, and they can be difficult and challenging to manage. I mean, I've been on that side, and I've also been a manager of these people. We're special people. So I think understanding how we operate versus, a generalist staff member, someone who comes from a policy background, for instance, everyone has their unique strengths and weaknesses, and I think each group or cohort needs to be managed slightly differently. So with data scientists, you're really looking for them having strong quantitative skills, being able to work with data, question data, vet data and technology to try and find which one is the right actual tool and data to use to actually solve your particular strategic problems. They need to understand machine learning these days. They're not data scientists if they don't know what machine learning is. And they need to be able to code. Most often it's R and Python, but I think actual true coding skills in things like C++, Java can be paramount to some of these people, and we can talk more about that later. So it's really having a deeper knowledge of coding and development where some data scientists can struggle, and where I think, depending on the organization's needs, if you have some research components that are important to you, it's important then to vet those people and have the right ones to meet your needs. With the engineers, of course, they need to have the strong software development skills. Coding in these days is really about productionizing a lot of data science capabilities, machine learning models, and working on distributed platforms, things like Hadoop, Spark, Scala. Understanding how you go from dev, working with the data scientists more on the development side, to taking that and productionizing those capabilities and then maintaining it and doing all the pipeline work and support around that, which can be important. So those 2 are absolutely crucial roles. And then sometimes for organizations, they'll have business intelligence specialists, people with visualization and dashboarding expertise to complement this work. More often than not, it's data scientists having to do that themselves. But for some organizations which have large capabilities and large funding, let's be honest, they can have a suite of professionals with different areas of expertise in the organization, and that can be great. And then you've got your business analysts and your SMEs, which are actually pivotal. You really want to be able to partner your data scientists and engineers with those who have deep domain knowledge. So these people can either be sitting in a business unit or those that kind of straddle both worlds, and that can help the data scientists and engineers also understand what the data actually means. Often in many organizations, as we all know, data is not, well, it's not explained very well. You don't have metadata, you don't have comments in your code, you don't have SharePoint sites which tell you exactly where this data comes from and what purpose it's used for. So having people with deep domain knowledge that understand that data can be pivotal to helping your data scientists actually use it for what it needs to be used for. And that's something that can often be skipped by some management staff. They don't realize the importance of these collaborative teams and the merit that they have. So that's the first tier. The second tier is the manager or technical lead sitting above these people, which I think can often be the most difficult role to fill. These people are really the linchpin in the organization. They have to understand the technical capabilities of what the staff are doing, and they have to also understand the business side. They need to be able to translate from business to tech, and then from tech to business when you've got results and output to show. I think it helps in competitive environments for this person to have Google cred, and by that I mean if someone Googles the manager's name, do they have some presence? Are they prolific in I don't know, in coding, in doing something? The reason why that can be important is it helps with attracting and retaining key staff. And as many know, I'm sure, attracting and retaining staff in this day and age is extremely difficult. So having people in management positions where those who support them can look up to them and say, look, I can learn from this person. Like, I want to move up into their role. I want to be associated with them. That can be a huge bonus. It's not necessary. It's not always easy to do, but thinking along those lines can really help when you're developing a new team or trying to restructure an existing team. The technical knowledge is important. If they've just come from a more policy or analytics background that isn't as deep in data science relative to what the team is doing, then it's much more difficult for them to support their staff, to vet and validate some of the work the staff are doing, and to translate technical potential to senior management and to say, this is what we can possibly do given the data we have, the remit we have, and our strategic goals. So trying to find people who are technical enough, they don't have to be necessarily have come from a technical hands-on role. They can help, but as I've seen in my career, some of those people aren't always necessarily the best managers. You don't want them in management roles. They don't work well with managing people, and everyone has strengths and weaknesses. That's fine, but it's identifying that and knowing which of those want to move up into more of a leadership managerial position and supporting that. So often you need to have support around that. You can't just assume, if they've managed technical, that if they've done technical work, they can suddenly manage technical teams. It's not often that simple. And the key role that they play is to turn viable business problems into measurable technical solutions. The word viable is purposely put there. They need to be able to identify what problems should we solve, not just any problem that's thrown at them or any problem that looks good. Which problems align to the strategic goals of the organization, and which problems serve our needs. And there's many aspects to that. It's very specific to the organization and the team they work in. It could be the data they have, the tech stack that they have use of, if they can't necessarily go out and purchase new data. What problems should we be focusing on for strategic benefit? So it's really up to them to understand what senior management is speaking about in terms of some of their overarching issues, and then going back to the team and saying, this is what we need to focus on, and this is how we go about doing it. So that was tier 2. At the topmost tier is this critical role of a CDO or someone equivalent who's a senior data leader. The reason why this is crucial is if you're trying to promote and push data science from the bottom up, you'll often fail. It needs to be supported from the top down. You need someone at a C-suite decision-making level that can advocate for you, source funding, and push down barriers. It could be barriers around silos, data sharing, technology, many different aspects, broader data literacy. There are so many components to this. They need to promote and advocate for a data culture. The cultural element is absolutely key, and we can talk about that all night. I've just touched on it here. They need to create that data culture that supports the organization. If you've got great data scientists and you throw millions of dollars at your infrastructure and your capability, but you have a poor culture, more often than not, you won't have the results that you need. You need the right culture behind you. You need the right culture in your senior executives, and you also need the right culture in your broader staff so they can work well with data scientists, they can collaborate. You need cross-disciplinary teams effectively. And it's a culture that supports that, where everyone thinks the data is ours as an organization and we're here to meet the needs of the organization and we should work collectively rather than data science and IT being in silos and sitting separately to the organization. You don't want that scenario. You don't want people thinking that data science is a separate specialist unit. It has to be integrated more broadly throughout the organization. They also have to, as part of that, support enterprise-wide education, which could be broader data literacy uplift, or it could be specialist training for some staff. It could be ethical and responsible AI training for everyone in organizations, for C-suite. It could be technical upskilling in terms of R and Python coding, or it could be something a bit more specific to the needs of that organization, how to work with their data within the governance and legislative frameworks that they have to abide in, which is often a key issue in the APS. The data strategy is also key. It sets out the roadmap and the vision for the organization. They have to be behind this. They have to push and advocate for it. So everyone in the organization understands what is the data and analytics strategy for that company, and what role does everyone play in that. So they have the ultimate accountability for data analytics. You need someone who's responsible. So when things go wrong, you can point to that person and say, you're responsible, rather than people throwing their hands and say, it's not my fault, which happens a lot. So the cultural element, I said I'll touch on this a bit more. The culture needs to be one that's around innovation and exploration. Remember the science in data science? You need to have the room, the capability, the freedom to innovate. You can't have a regimental system or a process-driven system like traditional IT that works in IT and needs to work in IT. With data science, it's a little bit different. You need to have collaboration. And one of the key elements of that, which I already touched on, is collaboration between your technical experts, your analysts and data scientists, and your business domain experts, people who actually use the data for some other purpose in the organization. It could be Intel analysts or in an intelligence community, for instance, just to use an example. You need to be able to have the two working together so they understand how to leverage the data and the domain knowledge along with emerging technology to actually provide viable outcomes and drive decision-making for the senior executives. The culture also has to be centered around sharing data, sharing knowledge, sharing resources. And by knowledge, it's not just, hey, these are the great successes we've had, also the failures. We've tried this, it hasn't worked. You need to be open and honest about that. For many data science people, that can be difficult to understand. We're very detail-oriented and have high expectations of ourselves. I learned early in my career, it's not really the best way to go around it. You really want to reach out for support, and that's where the right manager at the tier 2 level can support and promote that, advocate for that. So sharing is really important. Getting people working together rather than isolation is really key. And this mantra that often comes up in the startup space, fail fast, fail cheap, but learn heaps, is something that pockets of the APS in certain groups kind of adhere to, but is difficult, which I understand. But it's really around having the freedom to explore, that you can go down a path. It may not result in a direct outcome, but not to think of it as a failure or wasted resources and wasted time. You're learning something from that process. There's a reason why something hasn't worked, and you share it with the rest of the organization so they don't do the same. It's really about having the freedom to explore ideas and work together without having, I guess, unrealistic expectations around what you may or may not find. When it's too rigid and inflexible like that, it can be very hard for your data scientists to feel that they can work their best and to be in an environment where they feel like they can also add value and see how they're adding value to the organization. So you need to really support that. And that comes at tier 2 and tier 3 level. One important thing we should talk about that we touched on is data science. Data science is not IT. Some people are nodding and they understand exactly where I'm going with this. And that person happens to be a scientist by training. The real difference comes to discovery versus delivery. One is around solving problems, and the other one's about implementing solutions. They need to have a strong working relationship, a symbiotic relationship. But when problems occur, as I touched on earlier, is sometimes when you have the data function embedded in the IT function, or you have a CDO reporting to a CIO. You don't want that in your organization. And I recently spoke with a very senior executive I know for one of the large banks, and they mentioned they actually just separated these two. They had endless problems and they separated these two functions. So I was very happy to hear that. You can still probably get it working at some levels, but it makes it much harder for the secretary or the deputy secretary, DCOs to actually get this function working within the APS. So the mindset shift is quite important here. You don't want to run data science like IT. You want a great relationship between the two. But you need to understand the exploratory nature behind data science and that it needs to be managed differently. Often things like strict, regimes like agile and all that don't tend to work well. You have to be very careful with how you implement that in your data science team versus your data engineering team. So, word of warning, we can talk more about that later. So that was the people side. Next, we'll talk about the tools. Tools are important, obviously. Data scientists and engineers need tools to do their job. But what's imperative here? Open source, having a suite of open source tools, it's become a no-brainer for most organizations. But in the past, when I've touched on this, for some organizations, they've said, look, open source is difficult for us to manage and maintain. We've got a suite of, traditional tools that we've always used. Why do we need open source? Well, if you're not using open source, you're not using tools like R and Python, at least some open source elements and others, your data scientists won't be as effective and they probably won't want to work in your organization. So a number of reasons for this, but you want to have a range of different tools available. It's really a suite of tools that they can pick and choose depending on the problem they're solving, which is really important here. Having that flexibility rather than just rigid set of tools that need to be used for every problem. That doesn't work at all. Distributed data capabilities are becoming the norm, even across the APS. It was more so in the past in the private sector where I was talking to organizations that were using that. But now as cloud is becoming much more common and the ability to work on large, complicated data sets in parallel is becoming a little bit easier and cheaper, I think investing in that capability, being able to train your staff in it is really good. They'll have fun working on it and they'll also be a lot more employable, which is what everyone's looking for when they work for you. This notion of data ops, having the processes and frameworks and people who understand how to take whatever you develop, whatever solution you develop, it could be a model, it could be just a report on a regular basis from development to production is actually key. It can make the process a lot more efficient in terms of the project management and reusability behind it. So understanding some of the key notions and paradigms behind that can be beneficial for many organizations. Some will invest in ML ops, but whatever it is this operational element to understanding how to overcome some of those roadblocks that tend to be in place between dev and prod is really the key here, not so much the details of what paradigm you use. Having the right infrastructure to support, as we mentioned earlier, different types of data, not just tabular data, which is very traditional, understanding how to work with unstructured audio-based data, text-based data, graph databases, which is becoming much more common, is actually really important. Having the right infrastructure in place to give your data scientists a lot more flexibility in how they do their work. And I've seen organizations that invest a lot of money in data lakes and they'll go out and say, we've got this beautiful data lake that we've set up, and I'll ask someone who works there, how are you using it? I said, what? We haven't started using the data lake. It's not up and running yet. So having the support behind it, actually making it enterprise-wide for everyone is key, but not always easy. And modern tool stack, we've talked about this already. It helps with your capabilities, gives you a lot more freedom to solve different problems that you may not have thought of when you've developed your tech stack, so you need to modernize, but also helps you attract and retain good staff who actually want to develop their skills or utilize special skills that they have. There's merits in it and quite cheap these days compared to how it was done in the past. So that was people, tools, now data. Of course, we need data. Where do we come up against pitfalls though? Data quality. Obviously, everyone talks about data quality. One of the pitfalls is not just not having great data quality, more importantly, data quality which is sufficient to what you're trying to do. It's not investing in improving the data quality on a regular basis, going straight to the modeling, the infrastructure. That's down the pipeline. Forget that for now. First, invest in data quality and the right people, then worry about your, all the cool, sexy, fun stuff. That's all useless if you have poor data quality or you're not trying to continually improve it. And that could mean looking at new methods to label data for supervised machine learning. You could be cleaning up data that you source from a third-party vendor or from another agency, whatever. It's always thinking, how do we improve the quality of the data and the usability of that data? Also, the metadata behind it, the domain knowledge that supports it, that's absolutely paramount. Quantity, yes, for some organizations, quantity of data will be a potential, stumbling block if they don't have the right capability to deal with that. But these days, it's quite easy, especially through cloud infrastructure, to spin up and down, infrastructure as you need to deal with large volumes, even if it's real time or just one-off data dumps. So it's just being aware of what your needs may be in future to make sure you plan in terms of how you set up your infrastructure, but also the people and their capabilities, which can be important. If you're collecting a lot of data, how do you reuse that data? Do you need more than you have? Do you need all the data that you're collecting? For some organizations, they think more data, more value. It's not simple as that. Type of data, we've talked about that. Being able to handle and utilize unstructured data is becoming more and more common these days, much more accessible. And many organizations are realizing that they're sitting on some unstructured data that hasn't been used because they haven't known how to use, say, printed reports and using OCR and NLP to extract value. Suddenly, like, wow, data scientists can help us with this. Let's give it a go. Access to data, having CDO and other senior executives to break down silos. Anyone who's worked as a data scientist will know often accessing the data you need when you need it can be a real problem, a real roadblock to you doing your job day in, day out. So being able to come up with systems where maybe it's self-serve, data marts, the right protocols, processes, the right culture to support that is actually important. You need to make sure your data is fit for purpose. Remember, more data doesn't necessarily mean more value. How well does the data meet your goals? Is it representative enough? Are you just looking at a certain subset of data that really represents your customer base? There's so many aspects to that, but just understanding, is your data fit for purpose? Understanding the bias that may exist in it. That's becoming much more front of mind in senior executives when they ask their staff, what data do we have and what are you doing with that data? So I need to think about that quite consciously. And domain knowledge is crucial. Working with data as a data scientist in isolation from the business and from domain experts is a real problem and something I would never advocate for. You need to build strong working relationships and understand, what does the data really mean? How is it actually used? Thinking about that when you're developing your solutions is absolutely paramount. And sometimes it can take 6 months to a year to truly understand what data you hold, how it's stored in different systems, what business rules apply, and how to integrate it all together. And I've been down there in the past. So investing in that is really worth it. And to support that, you really need to have the right governance, risk, and ethics frameworks. Sometimes this is an afterthought for organizations. They get excited about data, they get excited about technology. Then they think, oh, maybe we should have some governance to support this. You really should be planning this in the early stages as you define your data strategy and as you think about the culture of the organizations. So having the right people on board early will really help drive culture, strategy, and the tool stack you need, and how you will use your data for strategic benefit. So having the right frameworks and processes, having data governance committees, having sometimes data governance, the data maturity assessment, which I do for many organizations, is often a real eye opener for them. Helps them establish the right framework from get-go, and helps them, it gives them a lot more assurance in what they're doing and with what the government or their clients may then ask of them in future. So when it comes to auditing and other aspects, they like to have this done right from early days. And these days, it's becoming much more important to think and design ethical and responsible AI, either policies or frameworks in an organization. But there are some challenges here. This may sound cool and fun, but not many organizations know how to actually do something with this. The first line is really shows you the crux of the problem. To go from policy and framework to actual pragmatic practice, for many organizations, they have no idea what to do there. How do you actually do that? They come up with some policies, or they download policies from a website, or a consultant comes in and hands them to them on a flashy piece of paper. But what do you actually do with it? How do you actually implement it in the organization? Part of that is collaboration, part of that is culture. But there are many facets to this, and it's more complex than we can really dive to in this talk today. But I'll touch on 3 important elements there that are in bold, 3 Ds. One is around your data. You really need to understand at a deeper level what your data represents, the bias within the data. I'll put a question mark after bias, but obviously every data set is biased. It's based on human data, which we're biased creatures. We'll pretend that maybe non-biased data exists. But it's really understanding, how does bias get in? What does a bias mean for what you're trying to do? What solution you're trying to develop, either for social good, for your organization, for your customers, clients, whatever it means. How does the biased data proliferate through the pipeline, through the modeling, through an outcome to a productionized system, for instance? What actual ramifications does it have on the end user? And technologists need to be thinking about this. They can't just think in isolation, we're just developing some tool or some interface. Data will come in, it'll be spat out. You need to really think, who are you affecting potentially negatively and adversely on the other end? When it comes to the models themselves, if you're developing ethical and responsible AI, you're trying to develop fair systems. How do you define fairness? How do you define it mathematically in such a way that you can encode it in your machine learning algorithm? What is fair to you may not be fair to one of your competitors, may not be fair to a client in another country. How do you deal with that? How do you deem that a model is fair enough to be deployed at scale on a production system? Explainability. That's one that catches people out. They'll say to me, we want an explainable system. And the first question I ask them is, explainable to who? To me? To one of your data scientists? To one of your engineers? To a manager? To an auditor? To a client? To a government official? I mean, there's different levels of explainability. Someone debugging the system needs a whole lot more granularity than someone who's just looking at the outcome and thinking, oh yeah, that looks, I kind of understand how you got the answer, that's good enough. So as people talk more and more about deep learning applications, ChatGPTs and large language models and techniques like that, straight away, many people will ask, well, how explainable is that? How do I know how it works? And you don't really know how it works, and that is a problem. For some people, it's really a problem. For some, it's fine. They kind of have a general idea, good enough, better than what they've had before. But for many organizations, especially in the government, we need much more justification of how we develop some of these solutions, especially when people can be adversely affected. Then the whole diversity element, which is really crucial to this. How do you develop ethical and responsible solutions if you don't have diversity in your team? If your team is 3 white young males developing these solutions that affect everyone, how is it possible to have truly representative notions and thinking? Because they make a lot of decisions throughout that process. So one thing that I advocate for strongly with a lot of affiliations with universities is trying to get the diversity and inclusion notion and some of the, I guess, thoughts and ideas in the minds of young people as they're studying, not as just one unit in their studies, as one course, but actually integrated throughout their entire curriculum. It may take a while to happen, but some universities are at least doing it as one course. Before you graduate, you need to understand some of this. This needs to be front of mind of those of us who are technologists and develop these solutions that can affect everyone. And we've seen when this goes wrong. I won't mention RoboDirt. Value. What we mean here is this alignment that I mentioned earlier in regard to aligning your data science capability, your data science machine learning models, to the strategic value of your organization. You need to be very mindful of how you do this. I'll never forget once when a large organization asked me as a consultant to come in, and the first thing they said to me is, tell us about our data. That to me is a huge warning sign. What is your business problem? Oh, we don't really know. Okay, we can go 2 ways here. Either get another consultancy who will charge you a lot to answer your first question about your data, or we can work together to define that business problem and refine what approach you need to help you. They didn't like that answer, but in the end, they came around and realized, yes, we do need to understand what are our business problems and why do we need data? They thought they needed a big, expensive machine learning capability. In the end, they didn't. They needed something that was very small and cheap. And they were quite disappointed that what I gave them was quite small and cheap, even though it surpassed their expectations in terms of value driven, because the CEO expected AI. I want AI. What is AI? I'm not really sure, but it looks cool. Like, my competitors are using it. Don't I need it? No, you don't need AI. And your competitors aren't using it either. They're just selling you a dream. And part of that is really knowing how to solve the right problems that once again link to the strategic goals of the organization, and focusing on, I think one thing that many data scientists in organizations can miss is focusing on user experience, in thinking about how will the data model solution that they develop actually be used on a regular basis. I've seen cases where people have developed excellent models with high accuracy rates, but the interface was so cumbersome and so poor that it just wasn't used on a regular basis. All the time and money invested in producing that solution effectively was a waste. All they needed to do was to confer with the client on an iterative, regular basis to kind of test ideas. Does this solution work well for you? They would have quickly realized that something a lot simpler and easier to use and interact with would have been much better than their complex, over-engineered design. Measurable outcomes. Measurable outcomes are important. You want to justify what you've done and the value it brings to the organization. And this is not talking about area under the curve, ROC, and all that. This is talking about dollar values, FTE, efficiency. I always tell data scientists, you need to focus on how what you do benefits the organization in jargon they understand, not in technical jargon. You leave that for the discussions you have with your team and at geeky meetups. When you're in the business environment, you do not drop any technical jargon. You're there to be seen as a trusted advisor, not a technical expert. And that's something that they struggle to, in their minds, to understand. But I'm a technical person. Like, yes, you are, but you're there to deliver strategic value for the organization. The technological strengths you have are just a means to an end. Don't focus on that with people who may not care about, the difference between, NLP technique you're using versus, convolutional neural network. They don't care about that. So just focus on the outcome, how it benefits them and how it helps solve their problems. And the more senior you go, the more you focus on that. You definitely do not talk about machine learning techniques to a CEO, which I once saw happen in a lift and did not go well for that young data scientist. And part of that is understanding what keeps these senior data leaders awake. What are some of the pain points and problems they're facing? And that is really about people again. Remember, the people element's important. Understanding what are they struggling with? What are they driven by to add value to the organization? And how can you use your strengths in data and analytics and engineering to help meet their needs? And one of the last points really is around communication. As I said, the people, the first one, and communication, the last one, I think, are really paramount to success in data science. But as part of this, it's knowing how to understand. It's the communication element, which those of us who are technical can struggle with. It's understanding what people need. They won't always define their business requirements in easy to understand terms. Sometimes the only way you'll learn that is through informal chats and discussions with them and their team to get to the point where you understand what they do day in, day out, and where you can come in and add value. They won't always define. Sometimes they'll come out and say, we need an NLP model to help us process this text. When they do that, you need to step back and say, this person does not really understand NLP. Why are they asking me for an NLP solution? So don't trust that. You need to question, what are you trying to do? What data do you have? What are your KPIs? What is your remit? And then go back and think, will an NLP solution deliver value? Do I need to be doing something else? Can I just do something very simple in Excel to give them a solution, which sometimes works? So not focusing on technology, but focusing rather on what's the quickest, easiest, simplest solution I can give them, which also is easy to validate, is explainable, and gets the job done. You only add complexity as you have to. You don't straight away go to the most complex solution because you think it's cool and because you studied it recently on an online course. One way to help with communicate between the technical and business worlds, I think, is through proof of concepts, roadshows, demos. Getting people involved and to interact with your solution is really important. Try and break down those barriers. Some people can be quite apprehensive and feel, insecure when it comes to technology. They might, they'll look at you and think you've got a lot more technical depth than they do, so they don't really understand what you're trying to produce for them. You don't want people feeling like that. You may have expertise in that area, but the solutions you're providing are ones that people use on the other end. So make sure that you develop those strong relationships to understand what solution works best with them. And then, through an iterative process, take them through this. Take them through a demo of what you're trying to produce. Early days, just a simple proof of concept, rather than go back 6 months later and say, here's what I developed for you based on what I think I should have developed for you. That often does not end well, and you don't want to work like that anymore. We've done it in the past in IT. We don't want to work like that anymore. There needs to be this agile, iterative development. User experience, once again, is important. And that translation element that I talked about is going from business to tech, and then tech to business, defining the business problem, coming up with a technical solution, and then translating those solutions to business terms, non-technical jargon. That's where the tier 2 manager, the technical manager of the team can really help the staff as they straddle both worlds. They're really the linchpin. Accuracy versus explainability. This can often be difficult when you're developing some solutions. Sometimes the more accurate you develop a solution, the less explainable it is. And I've been in these cases where I developed a solution for in the past for a client using a particular technique, which was a little bit more accurate than a simpler technique. But we thought they wanted a higher accuracy solution initially, but we quickly realized that what they really wanted was one that was explainable, they can explain to their senior managers. So we had to forego some accuracy to develop something that was much simpler and easier to not only understand, but embed in the existing system, which had a lot of rules-based approaches. So going down the path of high complexity and neural networks was not needed or of interest to them. That just wouldn't have worked, even though for us, it was the most obvious solution. Once again, trust is important. It's all about people. It's all about communication. It's about being seen as trusted advisors in your organization and not just a technical expert. Once you crack that, I think people realize their career can really grow and they can be seen as someone who is not just this technical geek sitting in a corner doing impressive work, but someone who's there to facilitate the broader strategic goals for the organization. I think that's important for anyone who works in this data space. Thank you.
Thanks, Alex. I think two things that have come out for me is how you've bookended the talk about people and communication, because unless you get that bit right, the whole thing just falls apart. So the people piece is just so important. And the other thing that I picked up was something that I was talking with the other Alex in our audience today, is how important it is to set up the systems correctly before you then start pumping out whole lots of data. So making sure that's all right. So data in, data out.
Exactly.
So thank you so much for a really, really interesting talk, and it's great to have had you here today. So are there any questions from the room?
Thanks, Alec. That was really good, really insightful. Thing I want to touch on is data ownership. You mentioned a bit about governance, culture. What I've seen in organizations and in departments, the way they're structured and the way the governance is set up and the way operating models are set up is very much against sharing of data. You hold kind of empire on. How do you see that in terms of developing and change of governance? Take that away, kind of have a more shared data, maybe a completely different.
Fantastic question. I've seen exactly the same thing. It ultimately comes down to having the right culture, which has to be driven from the CDO level, the senior leadership level. Having a culture that really supports this notion of data custodians in the organization. No one owns the data per se, they're custodians for the entire organization. So having someone who can promote that and identify the right people who have the skills and knowledge to act as custodians and stewards, data stewards, is absolutely paramount. It has to be reinforced and pushed from the senior leadership and made clear to people that we have processes and frameworks and technologies in place to help everyone use the data for the benefit of the organization rather than it residing in one unit who have sole ownership. So even change in wording in, say, a data strategy from ownership to custodianship can make a big difference, but it's a hard problem to solve. It's a cultural change. 100%. Yeah, exactly. And you don't want that. It was done traditionally. I agree with you completely. But once again, it goes back to the cultural change that's needed, and that has to be driven from senior levels. You can't affect cultural change from the bottom up. I mean, if people can, that's amazing. I'd love to see how it works. But thank you. That's a great question.
Yeah, I actually have two questions, probably one technical and one non. Sorry, one technical one and one non-technical one. First, in terms of technical perspective, past over a decade, we have been using backward propagation mostly, and that has helped in improving the models and all kinds of things. So recently, not just recently, but at least for past half a decade, they've been exploring different ways of training the models. And one recent one by Geoffrey Hinton himself, who proposed backpropagation. He proposed forward propagation. I just wanted to know what's your perspective. Like, do you think back propagation is the way going forward, or that's a bad algorithm to train your models? for new things. That's the one. The second question was, in your talk, you have mentioned about not speaking much of technical terms with your higher C-level people. In terms of my perspective, what I feel a bit opposing on that because the models which we train today are good for today's data. But once as the society moves on, new data comes in, the models or the predictions may not be appropriate, or the algorithm may not be appropriate. So the C-level things, we have an AI model that's running, but it may be outdated. So I think it's important for them all to understand bit of technical knowledge, what algorithms have been implemented and what is the limitations of it. So what
Yes.
do you think of that side? Like explaining them
Yeah.
what doing it.
Great question. So the first question, we have to be careful not to go into too technical talk today. It's not a lecture. I mean, so I think there's merit, but also limitations to most of the techniques used within deep learning. It's very much driven from, I think, the problem you're trying to solve and understanding some of the nuances around that and why back versus forward or whatever technique you're looking at would work better than the other. Normally, when I manage projects along this, we just defer to the current literature and research literature to try and determine, and sometimes we'll just do a suite of techniques and determine what's best for us. Because often something that looks great in a paper may not actually work very well in practice. So I don't always just take things for granted when I've read it, even by one of the greats like that. Like I think in isolation, one can definitely be better than the other, but in practice, it's never that simple. So sometimes it's really, I think part of that is having a strong R&D capability within your data science team is really important. Having people dedicate some time and energy to doing research and development can be of huge benefit to an organization, but often there isn't enough time to do that because of BAU, and that's often a problem. So I always try and develop capabilities in my staff to have an opportunity to do some R&D. The next question is more interesting, I think, in regard to senior leadership. And one thing that I think really helps with that is having enterprise-wide data literacy and really having strong programs that the CDO should support. So their C-suite colleagues understand enough about data science to be informed and to ask good questions. They don't need to understand intricacies behind different deep learning ML approaches, but they need to understand, at least at a conceptual level, when you're explaining pros and cons of something, why one is more beneficial to the organization than the other. So in this case, it may just be the fact that you need to retrain the models, sometimes some particular models, on a more regular basis. And that has implications on funding, on resourcing, on downtime, on a system, whatever it is. So just them understanding some of those concepts, I think, is really what's important there, rather than any of the technical nuances. You don't need them to go down to that level, and they won't care about that. So it's really understanding how to translate what is most important to them in that context in a way that helps give them assurance that you know what you're doing, but also they need to listen and understand what are the ramifications of this. And part of that is trust and having the right people in those roles to promote and advocate some of those details up the chain.
So I think that there was probably one question that we have time for from the online audience. If Jeeves would like to ask his question, we're just taking you off mute. While that's going, then perhaps there was one really interesting one that I saw pop up on the screen there before. What is the most common mistakes made by aspiring data scientists?
There's several. The most common, I think, is focusing too much on technology and not enough on communication and people. Focusing too much on what they can do relative to what the organization needs, which comes down to understanding what are the real business problems that the organization faces, and then how do they find the easiest, simplest, most direct solution to achieve the outcomes. So you need to focus more on business outcomes and questions rather than the technology itself. That comes later.
Right. And the question from Jeeves is, as predicted, production of 643 exabytes daily data by 2025, have we already lost the battle for data privacy and ethics? And what would you what would be your recommendation for this issue?
That's a really easy question to answer. I don't know. No one knows. Privacy is a huge challenge, as various breaches of late have shown. There's two aspects to this. One is we're very lax with sharing information with certain vendors, technical giants, and yet we're very skeptical of sharing information with the government to try and supply quality services to us. That causes a huge raft of issues. I think ultimately what needs to happen is for us to have more control as citizens, as consumers of our data, and that may take a while to get to that point. For now, it feels like it's a never-ending challenge, but there are emerging technologies such as privacy-enhancing technology, which can be leveraged to help work within the current legislative and societal bounds to help drive impact and fight crime and do all that cool stuff that needs to be done whilst protecting our privacy. So I think in some ways technology can be blamed for this loss of privacy, but also can be used to help us. Beyond that, it's this notion that technology moves much faster than legislation and regulation. So they're always playing catch up. That'll happen for the foreseeable future, unfortunately. But as Europe and the UK is showing, as these new policies and frameworks, GDPR, things like that come into force and are promoted and accepted more broadly, I think the future is still bright. It's just it may take us a while to get there. There's a lot of complexity there, a lot. So striving for responsible AI and ethical AI, as I mentioned, and the privacy implications is non-trivial, but we're at a point now in history where I think we can make a difference. We need to all be active and voice our concerns. So I'm still positive, but I can see challenges in the foreseeable future.
Well, thanks, Alex. That's been really interesting, and thank you for everyone for your questions. It's been a great discussion. As I said before, it's a really interesting field, and where it's going, it's just going so quick. But I really enjoyed your point around connecting with strategic objectives and connecting what you're doing with people. So
thank you.
Thank you very much, Alex.
My pleasure.
Now I'll just do the final finishing off. So certainly what I encourage everyone to do, those online as well, is to make sure that you talk about this event and what you learned from this event and tag on the various social media platforms that we have. And of course, your feedback is really important to us. It's how we learn what it is that you're looking to hear about. I know that there's plenty of more technical or more in-depth areas in data science, as Alex has mentioned, that we can go into. But what is it that you want to hear about so that we can start to help to deliver that? So please leave your feedback. It would be very grateful. Upcoming events, of course, go to the events at the ACS events website. And coming back to that last question around privacy and things like that, of course, don't forget that the ACS releases a number of different reports, and data sharing and privacy and the like are in a number of those as well. So feel free to go and having a look at those reports as well. And on that note, thank you to everyone who's joined us online and in the room, and I hope you have a good night. Thank you.